All right, kids, this sheet here is pretty short. It's just a couple of problems. They're good problems though. So I really think it's in your best interest to try to do them yourself first. I will tell you that for number one, you do need a little bit of trig. Okay. For the second one, you don't need any trig at all. You should be able to do the second one with no calculator, actually. So maybe give it a try. Maybe pause this here and see what you can do. I will tell you the answer comes out to 5.25 for this first one. And the second one comes out to 10/3. Now I am going to walk through them, but I think you'll get more benefit if you try this yourself first. Okay? All right. So I'm going to label the information. 20, 14, and 12. I'm asked to find the length of arc EF, this arc right here. So obviously to find the length of the arc, I need to know the radius. So I need this radius. I'm going to call this X. I think that would be smart. This would be X as well. And now I'm going to walk around both ways. So I meet on the far side, and I know that 12 minus X plus 14 minus X has to equal 20. So I get X equals 3. So the circumference of circle C is 2 pi times R, 6 pi circumference of circle C. So we know the circumference. Now we just have to take a portion of that, a fraction of that. So to do that, we of course need this angle because we have to figure out what fraction we're talking about. And to get that angle, you are going to need some trig, right? You know 3 sides of this triangle. You need this angle. So yes, use law of cosines for angle C. So that would be what? You'd have 20 squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times cosine of C. Okay. You can go through this yourself. Remember, you're going to have to do, well, I can do some of it with you, I guess. Let's move some things over. If I move this over and that over by subtracting, I'm going to have 60 equals negative 336 cosine of C. So I want to do inverse cosine of 60 over 336. And I come up with angle C to be 100.29 degrees. Okay, so we're going to take that circumference of 6 pi, multiply it by what I just got over 360, because that's the fraction we're talking about. I did not hit reset on my calculator. Carried it all the way through. And this will end up, whoops, my pen this will end up giving us 5.25 units. I did it all in decimals just because you had to use trig and you got some messy stuff there. So I multiplied the pi out. So that's how you get 5.25. All right. Okay, the next one, no calculator at all here. No trig, no calculator needed. Let's go ahead and mark some of this information. We got congruent circles. And, you know, we have xy is 8. That's good to know. RP is 1. QS is 1. I like to draw in some radii, though. Whoops, that's not going to come out too good. Let's try again. So if I draw in, and I draw in that, remember the circles are congruent. So all 4 of these segments that I just drew in are going to be congruent. Okay. Now, the secret here, I hope you realize, we talked about this before. This segment here that goes through the centers of the circles, it's going to be the perpendicular bisector of this common chord going up and down. Okay. We've discussed that before. You know, you can get that from triangles, from the triangles being congruent. Now, that means that this upper part is 4. And I don't know what this is, but I'm going to call this x, and this would have to be x as well because these two triangles are going to be congruent. Okay. Now, this is where you got to think. So, we're talking about circle P. So that means from here all the way out to here is also a radius of P. And then circle Q, you get the same thing from here to here. You see this radius of circle P, x, x, and 1. The radius is 2x plus 1. So that means this part, this is also a radius of 2x plus 1. So now we got a little Pythagorean theorem going with this skinny little triangle here. 2x plus 1 hypotenuse squared equals leg squared plus leg squared. So I'm going to go ahead and expand that. Okay, we're going to move this over. 3x squared plus 4x minus 15. We got a quadratic here. 3x and x. You're going to do 5 and 3, minus and plus. X equals 5/3, x equals -3. Of course, x can't be negative in this particular problem, so that gets crossed off. So x is 5/3, okay? So that means that PQ, of course, is twice that, and that's where the answer of 10/3 came from. So some of these problems can get tricky, and you're going to see in your homework assignment that there's some tougher problems there, okay? Do the best you can. Remember, there's office hours every Monday at 11:20. This will come back here in a second. There it is. Now, the second sheet that's available for today, there's no video with that. It's pretty straightforward, I think. It's just additional practice with walk-around problems and different stuff like that. The solutions are on Canvas. And the link is on the homepage. I think you'll be able to figure out this stuff as you go on that second sheet. Okay? All right, that's it. I'll see you.